So, what I did is I added on to it. Did I add the second bulb in series or did I add it in parallel?
Series.
Parallel. So here's how I know that it's added in parallel.
Because you can take it out.
Because if I cut that connection, the other bulb still goes.
Oh,
Okay?
Oh, great.
Now, I'm going to reconnect that. So, what this is known as is a contactless ammeter. So with this one, and all you have to do is like move it over it, and it tells you what the current is. And this actually exists. Okay, we'll go out and we'll show you. I'll show you how that works with the solar panel. So because as current flows through, it generates a magnetic field. So basically, what it does is it measures the magnetic field and it changes the distance number. So the old school way of measuring amp meters was that you had to like connect it to it, and you would measure, and it would become part of it. Okay, so you'd have to like hook that in. So the contactless ones, the beauty of that is all you have to do is just move the sensor over and it gives you this number. Now, here's what I want you to see. This is what's known as Kirchhoff's rule. So the current here is 1.35 amps. The current over here still 1.35.
Oh, it has to stay the same.
Okay?
One in the middle.
Put on the resistor.
But if I put it in the middle, that's 0.45.
Why?
Why did you divide
Now remember this number, 0.45.
Okay.
But if I move it up to there,
it's
that's
double.
0.9. So down here it was 1.35.
See.
There's
It's a third.
0.45.
Oh, it all adds up to that.
And there is
0.9.
Yeah. It has to add
Ah, Kirchhoff's law says that sum of the current at any point has to be the same. Right?
See.
Makes sense. Now,
It does.
here's the deal.
It's a resistor.
And we'll talk a lot more about this later. But why do you think the current there is 0.45 and the current up there is 0.9?
The middle
They
one.
both have the same light bulb.
The middle one has a resistor.
The middle one has a resistor.
Yeah.
So what?
So
It's gonna resist more.
it takes away the
It has to crush more.
Hey, listen to Shaq. Shaq has a good
Slow
idea.
down,
Shaq.
It flows the easier way.
Oh! Okay. So
Good one,
electricity.
Shaq, you took my answer.
Is it lazy prima donna?
Because Mother Nature's a lazy prima donna.
Yes, exactly. So Mother Nature goes, hey, what's going to be easier? To go through the resistor and the light bulb, or just to go through the light bulb?
Just the light bulb.
The light bulb. Okay, because that's going to be the easiest path. Now,
That was
it doesn't go to zero. Mother Nature isn't that lazy. Where Mother Nature goes, wow, okay, hey, I got a resistor and a light bulb. I'm going to put all of it up there to that upper light bulb. She's not that lazy, but there is a degree of laziness to that. But if I remove that resistor and take it completely out,
equals.
It's going to be
It's very half.
what's
1.35 divided by 2.
Yeah. Or just 0.9, that works too. Yeah.
Oh!
Oh.
Yeah, that makes sense. Okay.
That does make
That goes
sense.
faster.
why did the current go up?
I
Because
really
it's
can't
got
tell you.
Because of the
I took out the resistor.
Voltage divided by resistance.
Oh, no, don't worry about that. I took out the resistor. So since I took out the resistor, what happened to the amount of current?
Really
Up.
confusing.
Up easy.
Oh, it went up. But now notice that still gets split. Now that everything's the same, that's going to be 0.9 and
0.9.
0.9.
Why did it go to 1.8?
Yeah. Because difference in voltage is over.
Because the resistor.
You take out the resistance there.
Take out the resistance and
Yeah.
use the amperage.
Jen,
So the sum, you said the guy's rule.
Kirchhoff's rule.
The sum of the current at one point equals the sum of the current at every.
Yes, after it's split.
Oh, the resistance.
Oh, it's just like after it hits something.
Yes. If you can visualize it
There's less resistance.
somewhat like a river. So here's this river, and it's flowing at, say, I don't know, 10 cubic meters per second.
Yeah.
Right, so that's your flow rate of this river. And then it would split, and maybe this might be 3 cubic meters per second, so that side would have to be 7 cubic meters per second. Okay? Now, you're going to have a problem on the assignment for the book, and it's going to have like negative amps, which doesn't make any sense at all. Okay, I don't know why they do it. They've done it this way like in 2 different editions, and it doesn't make any sense. So when you're going to see a problem with Kirchhoff's rule, and it's going to have like negative amps, don't worry about it. Just treat it as like an absolute value. Okay, so the negative, I don't know what they were even trying to say with that. It doesn't make any sense. So don't flip out if you see it. Just still make everything add up to it. Okay, don't get hung up on the negative one. Okay. Huh?
What? He's like, time flies by when you're having fun.
I mean,
I'm like, it did not. Who is that? Okay.
Stairmaster.
I disagree. Time.
What?
I'm
I'm joking.
It's not worth it.
I got SWATs.
just got like a
10 times 2, don't worry.
Oh,
Powerlifting, bro.
It blocks.
Please.
Dude, I had
Why we're looking here.
my legs are cooked
What's that
because I hiked on
I
Saturday.
can't do anymore.
I
think
we're done,
My
Colorado.
brain is.
I think a total of,
I'm about to take a nap.
I think it was 12 miles. So,
You're squatting today?
hey, bro, I gotta keep the program.
Hey, that's tough.
Oh, brother. No.
Ew! Oh, no, it's potential.
What?
I mean, for what?
Okay, so here's kind of the last big idea. So, if you look at what makes modern life really possible, one of the most important things that we have developed is the capacity to build small, high energy density batteries. Quit throwing stuff, Gavin.
Settle down.
Now, so imagine if we had, just imagine this, shocking as this may be, that we developed the technology to have cell phones and transmit information and all of that good stuff. But we never developed the capacity to have batteries.
Oh, we had to buy a phone every day.
Well, no,
Everything would have to be
No,
connected.
the phone wouldn't.
the phone would only
You get a new
work
phone
if
every
it was
day?
plugged into a wall,
Oh.
okay? Kind of like a toaster. You don't see battery-powered toasters,
I mean,
okay?
No, I don't think
Is it really
possible?
Well, you could, but it would take a big battery, okay?
How big?
Wait, so like how the phone
Depends on how much toast you want to make. Do we?
So like on like an average toaster, how big do you think it actually would be?
Huge.
I don't know. Depends on how much
Who else
toast.
does that?
Meters cubed.
But shh.
No, he got a
So here's the point of the story, okay? Is that batteries store electrical potential energy. And if you don't store electrical potential energy, your phone doesn't work. Now, if you look at this equation, delta U equals Q delta V. So this is going to be your change in voltage, right? Voltage is measured in what? Joules per coulomb. This is your charge, which is going to be in coulombs.
Cologne.
The coulombs cancel out. You're left with
Really?
joules. Now, let's think about this.
Joule.
When your battery is dead, what's the value of your delta V?
Zero.
Zero. Guess what? How much delta U do you have?
I think
I think like zero.
Okay, so this is what happens if you forget to plug your phone in for an extended period of time. You lose the delta V. You don't have any ooey. So what's the function of charging your phone at night?
You store
To restore the potential energy.
Yes, it pumps the water back behind the dam. Okay?
the water tank.
Yes, it gets the water full back behind the dam. That's what you do at night when you plug your phone in.
Real question, this is a good question.
Oh,
How come that, like, the battery on my phone, when I first get the phone, like, the battery lasts longer?
Has to do with something called dendrites.
Yep.
So dendrites are these little particles that grow on the anode and cathode of the battery, and that impacts the efficiency and how much charge it interferes with the flow of the ions across the battery.
Oh, yeah.
What?
How do fiber optic cables work?
What do you say?
Tomorrow I'll show you how fiber optic cables. All right.
Probably will.
Display more like data.
Have you ever thought about taking an eye drop?
I did.
I've been my arms are ashy.
Question.
So that means you smoke.
So we are on the.
Maybe, oh, God.
3 through 6.
Okay, that's it. 3, 4, 5, 6.
Everything is ashy. It shows that my name is correct.
That's it, just write problems. 1, 8. You got what you need. 2. That's it, that's it. Just say 2A. Oh. Well, even. Or something. Nope. 11, 12, 13, 14, 15.
That is not what it's not.
I'll take that. But it's first day back.
I've got to
Okay. Now, when you get to question 5, and you're going to see this more and more often.
Question 5?
Question 5. You have to rank them, okay? Like lowest to greatest, whatever that kind of is, okay? I don't do commas. So like on question number 5, you can put greater than, you can put less than, you can put some type of operator between those scenarios on question number 5, okay? So just keep that in mind. So like on question number 5, do not do commas,
Yes,
okay? So I'm just saying.
Hey, I'm pretty sure
All right.
the leader used that last one that wasn't.